Quality of our pipes is of vital importance to us. It's also quite difficult because all our pipes are under the ground. Digging is quite expensive, so it would really help us if we have a robot that can stay underground for a long time.
One way or the other, such a robot will be of use either for smaller missions or for the large-scale permanent missions.
We really hope to turn it into an industrialized prototype with which we can do experiments in the real world. The robot is inserted in the grid through an entry lock, which is pressurized. It can do a first sharp T into the network, and then it will start carrying out its inspection. During this inspection, the robot is controlled by an operator who controls the robot through a laptop and a control surface. On the laptop screen, in real time, data is feedback from the robot on its state, but also on the state of the pipe. During this inspection, all this information is gathered and stored on the laptop system. Then the robot can travel back and can be retrieved through the same entry lock.
The Dutch grid and also the Enexis grid is quite unique in the world. We have a very dense network with a lot of connections, a lot of turns, crossings, small diameters.
And at the moment they are not quite at the end of their lifetime, but if you can postpone the renovation of the system partially for say 10 years, then you save a huge amount of money.
We believe that if you can handle our network, you can handle any network in the world.
In 2006, our university was approached by KIWA to develop a robot capable of navigating in the Dutch gas grid, with one of the foremost problems being able to navigate a small T-junction in a very small diameter pipe.
The nice thing of the university is that a lot of different disciplines are available, because if you make a robot you need to be able to do the mechanical parts but also the electronical parts, the software, and there are not that many groups or people which are able to bring together all those expertise you need for building a robot.
I'm really proud of the way that we could collaborate as a team and integrate all the components necessary for making a mechatronic system at such a close level. Due to the 3D printing manufacturing, we were able to produce very rapidly changes and alterations in our mechanical design, which allowed us to incorporate the electronics and the wiring and all these details which are really important for our prototype in such an integrated manner.
The value of this project is twofold. One, it can do jobs that people do that will retire in about 10 years. The other value is performing inspections under difficult conditions, such as under canals or when there's a complex topology of your network, to do multiple turns under in small diameters. An inspection robot can help you do inspections in those situations.
Our robot consists of a double clamping V-shape, which allows it to clamp itself in any kind of piping structure. Since the grid consists mainly of smooth pipes, the robot uses simple wheels for propulsion. So that means that it's very energy efficient in traveling through the network, and also its range can be quite long.
The thing that really made me happy was when I first saw the inspection robot driving through the pipes. You can see all the things turning and moving. I thought, wow, this could really help us in tight spots where it's really difficult to get other inspection devices into our network. You could just see all the possibilities it could have.
In the minds of the people, it should be a routine inspection robot. It should not be a very experimental process anymore. And to make that step from experiment to routine operation, that's the challenge at the moment.
In the coming years, we think we will see more development of robots that can be used in actual situations. And we are confident that the pipe inspection robot will be one of those products that help us deal with the challenges we have as a grid operator.
Right now, we have a very promising concept, a very promising prototype, which, according to our tests, can do all the necessary maneuvers and is capable of carrying out the inspection task for which it is designed. The main challenge is to turn our robot into an autonomous system. So we're really waiting for investors to help us do the next step and industrialize this robot so that we can, well, have it out there in the real world.